Alright, so we're going to continue with chapter 8.4. The last time we started electromagnets. Today we are going to continue with motors and generators. So as you can see here, we are on page number 254. So I need to turn to page 254 on electric motors. So it's stated here that two magnets experience a force when placed within each other's field. Likewise, a current carrying wire experiences a force and moves whenever it is placed in a magnetic field. You see, in this case, electricity causes a magnetic field which causes movement. This too is part of the phenomenon of electromagnetism. As mentioned before, when we are talking about electromagnetism, you are talking about electricity supply is electric supply is required for that particular matter to become magnetic. So in this case, the coil can become magnetic as a result of electric current that is flowing through it. So the second paragraph says that an electric motor spins about its pivot because of electromagnetism. A current carrying coil is placed within the magnetic field of a permanent magnet. The two magnetic fields interact and the coil then spins because of the forces on it. This forms the basis of a simple motors. As you see, simple motors like these are commonly used in toys such as slot cars because these toys don't require much speed or power. Appliances like hair dryers and power drills need stronger motors and use stronger solenoids instead of permanent magnets. I mentioned before, if you're talking about iron, you're talking about cobalt, you're talking about permanent magnet, they always have the magnetism on it. But if you're talking about electromagnetism, they require the presence of electricity. In this case, it's powered by battery. As mentioned, battery consists of more than one cell. So in this case, it's powered by battery, as you can see here. So electric current flows through it. It will flow through that particular solenoid, or in this case, coil, or the metal coil, allowing the motor to spin. Bear in mind, the electric motors do contain both the presence of permanent magnet and the electromagnet. In this case, the electromagnet is the temporary magnet that is present. So that particular coil will be spun by the presence of batteries. And at the same time, the magnet that is available on the side, or the permanent magnet that is present, will also enable the motor to spin. So if you look at the diagram, say in an electric motor, current is passed through a coil. The magnetic field it produces interacts with permanent magnetic field of the motor, causing the coil to spin. So this is in general how an electric motor looks like. I'll move on to the next slide. So this is on generators. I see that the electricity available from batteries is useful for portable devices. However, voltages and currents are far too low for most purposes around the home and in industry. This is when a generator is needed. A generator uses electromagnetism to generate electricity. As mentioned before, when we were talking about a motor, in this case a generator, they do use electromagnetism to generate electricity. So you must be able to know what energy has been transformed. It is in this case being transformed for generator is transformed from electromagnetism to electric energy. So I'll move on to the next slide. So once again, you have electric motor, you have generator. Make sure you know the difference between electric motor and generator. If you're talking about electric motor, it needs a coil, a magnet, and electric current. If you're talking about a generator, it requires a coil, a magnet, and a spinning movement. The difference between them is that if you're talking about electric motor, it involves the spinning movement. So it produces a spinning movement. It changes from an electric current to, in this case, the kinetic energy that is present from the movement of the electric appliance. So in an electric motor, it's converting electric current into kinetic energy or movement energy. If it's a generator, it converts a spinning movement into an electric current. So there is the difference between an electric motor and a generator. If you look at this particular diagram here, it's on generator. You can see that it converts the spinning moment or kinetic energy into electric current. So what you can see here is that initially you have water or steam causes blades to spin, which turns the pivot and coil, and it is then followed by electromagnetism that causes electric current to flow. So the general idea here is that you must have something that generates an electricity. In this case, it can use a turbine or it can use a blade, and when it moves, the energy will be transformed into an electric current. So make sure you are able to differentiate between an electric motor and a generator. And later when we talk about generator, there are many different specific generators. One of them is probably what you will find with bicycles. For example, you come across some bicycles that can power electricity or can power equipment. And what it does is it involves that spinning movement when you are pedaling the bicycle, ultimately allowing you to generate electric current. I'll move on to the next slide. Alright, so dynamos. A dynamo is a small generator that spins its magnet instead of its coil. Dynamos are often used to power the front lights. On bicycle, the wheel spins a magnet alongside a coil, and this generates a current inside the coil. So when we are talking about dynamo, it's an example of a generator. And what it does is that because of pedaling, because of movement on that particular bicycle, it will turn it, or it will convert that energy into electric current that ultimately allows you to power the lights on the bicycle itself. So you look at this, you have tire, you have wheel rim, the wheel turns and spin pivot, and ultimately, with the presence of the magnet and the coil, and that particular spinning process will be able to turn that energy into the electric current in the form of light, energy that is being produced on the light bulb of the bicycle. So you can see from this particular diagram here. I'll move on to the next slide. Alright, turbines is a simple generator produces electricity only if its coil spins. In contrast, a larger generator spins its magnet and keeps its coil fixed. Anything can be used to spin the coil or magnet. For example, many bicycles uses a small generator known as a dynamo to generate current to power their headlights. The dynamo uses the front wheels of the bike to spin a magnet within a set of fixed coils. And then it says here, a large-scale electricity generator is known as a turbine. Turbine needs to be spun at high speed, and different methods can be used to spin them. So when we are talking about generators, and we did mention about dynamo and we did mention about turbines, these involve movement. You must have movement to generate electricity. So in this case, because there's movement on that wind turbine itself, it will then able to use that energy and get it to be transformed into electric currents, which is why wind turbine is known as a renewable resource, because the energy is renewable. It is unlimitless or limitless. You can always generate new energy from that particular wind energy that you can get from the wind turbine itself. We'll move on to the next slide. Alright, moving water. There are a number of ways in which water can be made to spin a turbine. Hydroelectricity is generated by water falling onto the blades of the turbines, spinning them like old-fashioned but very fast water wheels. Wave power uses the regular swells of the ocean to rock the turbines back and forth. So this is on tidal power, uses the massive flows of water from the twice daily changes of the tides to spin turbines. So once again, anything that involves movement, you are able to convert it into electricity. If you are converting from movement to electricity, you are talking about a generator. If you are talking about a motor, we'll be converting electricity into movement. So make sure you know the difference between motor and generator. So if you're talking about turbine, you're talking about dynamo, or you are talking about spinning a turbine, which is what is being mentioned here, you're referring to as a generator, to generate electricity from movement energy or from kinetic energy. So this diagram here is talking about water rushing past the blades. As the tide comes in and goes out, spins the turbines to generate electricity. This then resembles an underwater wind turbine. I'll move on to the next slide. Alright, steam. The high pressure steam from power plants are used to spin the turbines. The heat required to spin the turbines can come from the following sources. It says here, burning fossil fuels such as coal and or gas, burning biomass, which is any biological material such as wood, leftover wood chips, sugarcane waste, methane gas produced by human and animal waste, geothermal energy, where heat energy from deep and in the earth crust is used to heat water. This is here nuclear power, where a controlled nuclear reaction produces the heat necessary to generate steam. solar power, where sunshine is reflected from mirrors onto a central furnace through which water flows. So when we are talking about steam here, it says that the steam itself is used to power or to spin the turbine. So how do you generate the heat? You can either burn fossil fuels, so you burning petroleum or natural gas, burning coal. You can even burn biomass, so it can be a biological material that you can find from dead woods or dead plant materials, or even to a certain extent human waste as well. The breaking down of human waste. Geothermal energy, it says that heat energy from deep in the earth's crust is used to heat water. Nuclear power, where a controlled nuclear reaction produces the heat necessary to generate steam. And solar power, where sunshine is reflected from mirrors onto a central furnace through which water flows. So these are the methods that can be used to produce the heat required to spin the turbine. I'll move on to the next slide. So these are the examples as mentioned, what is mentioned in the textbook. So they tell you which of this energy is renewable, which of this is non-renewable. In general, if you're going to burn fossil fuels or coal or natural gas, you're talking about non-renewable energy, because once they're depleted, then there's no more of that particular materials available. If you talk about wind, hydro, tidal, wave, biomass, geothermal, and solar power, they are renewable energy, and then there's explanation on whether they are clean or not. In general, if they produce carbon dioxide gas, they will be polluting the air. So they are not clean if they generate carbon dioxide or any other toxic gases. So these are the advantages and disadvantages. So you can go through this in general. If you come across renewable energy, it talks about this energy, usually they are reliable. If you look at this point here, minimal environmental impact. So there is a general idea in between when you're comparing these particular methods or this particular energy that you are using. If you're looking at biomass, it says they remove waste and carbon dioxide from the environment. If you're talking about geothermal energy, is free. Solar power can provide power to inner cities. But there are some issues to do with renewable energy as well. For example, if you look at wind, it says the output changes as wind changes. Turbulence from one turbine can affect the nearby turbines. They are noisy. If you're talking about, let's say, wave energy, the output changes as wave change. If you're talking about biomass, large amount of carbon dioxide emitter, biofuels use crops that could still be used as food. Just to clarify to you as well, I didn't mention about fossil producing carbon dioxide and water, but they do emit or they do produce other toxic gases as well, and that is the reason why they are not renewable or they are not clean in that particular sense as compared to biomass as well. Biomass only produces carbon dioxide because you're only burning those biological materials. So other of the toxic gases that you're talking about, let's just say anything that consists of sulfur, sulfur dioxide, or you're talking about nitrogen dioxide, for example, those are toxic gases that can be produced from fossil fuels or from the burning of toxic materials or materials that can be potentially toxic for the environment. Alright, so this is the difference in terms of the advantages and disadvantages of these different forms of energy. So I need to take a look and make sure you know the difference between them. I'll move on to the next slide. Alright, so this is on AC and DC. We did mention briefly. AC is alternate current and DC is direct current. So what is the difference between them? When you're talking about alternate current, it is suitable for industry and household appliances. DC is suitable for smaller appliances. AC voltages can be boosted or drawn using transformers. We did mention about transformer. It's like the moving transformer. You're talking about changing the current. You can either reduce the current or increase the current. Direct current will be voltages cannot be changed. They must match the voltage required by the appliance. And it says that AC to DC conversion is easy using electronic rectifier. DC to AC conversion is much more difficult. AC motors are relatively simple. Power output is higher than that of DC motors. DC motors are more complex than AC motors. Power input is usually low. AC transmission is low because AC voltage can be boosted for transmission. DC is high because DC voltage cannot be changed for transmission. For storage, AC needs to be converted to DC before it can charge or recharge battery. DC can charge, recharge batteries. You store energy as chemical energy. In general, if you're using, let's just say, a solar cell or using a battery, for example, you're talking about direct current. There is only one direction that electricity is for it. What you have at home, if you're talking about electric current going to different power, different cable in your particular home, you are talking about the use of AC. And how do we know? If you look at the wire itself, there are 3 different wires, and they mentioned one of the wire is the brown wire, which is the active wire, bringing electricity from the power point, and one is bringing the electricity back to the main source. And that particular cable is basically the neutral wire that we have discussed. So as for this slide here, if you're talking about the use of battery, for example, you're talking about just one direct current, so it is one direction. If you are talking about alternate current, you're talking about both directions. Electric current is coming to home, electric is going back as well to the power source. And the good thing about AC or alternate current, it can be transformed, which means the energy can be even be boosted up or it can be dropped using the transformer, and that cannot be done using the direct current. Something for you to think about. Move on to the next slide. Alright, so transmitting electricity, transformer is a device that steps up AC voltage or steps down AC voltage. If it's stepping up, it's increasing. If it's stepping down, it's reducing the voltage. A transformer at home will then be used to reduce the voltage even further to a level needed for electronics at home. 5 to 6 voltage to recharge mobile phones, 6 to 6.5 voltage for digital camera, 19 volt for laptop. And I did mention about how the voltage that coming to your home is usually 240 volts. So you're talking about reducing E. Too much voltage is going to your electronics. It can potentially damage the electronic equipment. So in this case, the transformer is used to reduce the voltage that is going to each of the equipment. Which is why if you look at your laptop right now, you have this large piece of like a rectangle device that is connected to your laptop itself. Is basically to reduce the voltage, in this case to 19 volt. I'll move on to the next slide. Alright, so this diagram here is summarizing how electric current can undergo the transformation process or the transformers on how they are being used. So initially you call stores chemical energy, it's called is burn, release heat, boils water, steam turns turbine. Is the electricity produced? There are transformer, boost voltage for transmitting this minimal power loss. Step down transformer, often in substations in a city's age, drops voltage to 11,000 volt. It says here step down transformer, often at the end of the street, drops voltage to 240 volt, and at the end of the day you have 240 volt available for use at home. That will then reduce further with the transformer that is being present for every equipment that you have. So initially you have a large amount of voltage. Initially at the end of the day, the voltage will be reduced to an extent that is safe for your equipment, which is why your equipment will not burn out. If it's too much of voltage, then there can be a potential damage to your equipment, and we do not want that to happen. Alright, so chapter 6.4 is done. I need to complete the questions based on what I stated on school boards. You're very welcome to ask me questions on social media or email me the question. I'll answer the questions, and then when we come back to class, we have a bit of discussion on this before we move on to the next topic for term 2. So we will have a bit of discussion on that. The next topic is electromagnetic radiation. If you want to go through that, so we go through electromagnetic radiation in the next few lessons. I'll see you then.